Hi, I'm Jackson.
I'm Leo.
I'm Jeffrey.
And I'm Noah.
And we are SNFS or SNFs, Civil Nanoparticle Filtration System.
Our mission here at SNFS is to use nanowire filters in order to contain silver nanoparticles and additional harmful materials in our water supply. From there, we assist in extracting and recycling these silver nanoparticles for more beneficial uses.
So, what exactly are silver nanoparticles? Well, you may be surprised to hear this, but all of you are literally wearing silver nanoparticles right now. There are probably thousands on your shirt. Silver nanoparticles are basically clumps of silver shrunk down into tiny size. You can't even see it with a conventional microscope. You have to get a specific kind to even see them. They're used in textiles, they're used in shirts, and they're mainly used for their antimicrobial uses. And because they're so small and there's so many of them, a lot of them get leaked into our water supply.
So how do silver nanoparticles enter our water? Well, there are multiple industries that contribute to the release of these particles into our environment, but the biggest contributors in terms of industry include cosmetics, coatings, filtration systems, and textiles. And what's interesting about textiles is that many textiles nowadays actually use silver nanoparticles for their antimicrobial properties. So going off that, silver nanoparticles have quite a few applications and benefits. For example, they, as I mentioned, they can be used for antimicrobial purposes, such as disinfecting surfaces, because they emit a steady stream of silver ions, which can combat the microbes. And it also has a number of different applications, which stem from three main characteristics of these particles, which is that they're very conductive, they're stable, and they have unique optical properties.
So, along with their benefits, there comes a lot of problems with silver nanoparticles. So, as all of you know, not all bacteria is bad. Actually, there's more good bacteria in our body than we have human cells. So, silver nanoparticles pose a threat to our soil, ourselves as humans, and our water systems. So, what they do is they, in the soil, they can go in and hurt beneficial bacteria that is helpful towards growing staple crops such as rice. In water treatment plants, it can kill bacteria that helps break down sewage in an effective manner. And inside our bodies, we can actually deplete our ways of dealing with pathogens, thus making our body more susceptible to sicknesses. So after, I don't know, probably 3 days of work, multiple man hours, sleepless nights, we've come up with a box. Not just any box, it's a filtration system. So what we have here is a multiple layered filtration system. So up here, you get water in from your water appliances such as washing machines and sinks. And what it does is it filters out the bigger particles and then filters out the silver nanoparticles, and then the water goes back into your main sewage line in your house. So this process would essentially be a closed system using gravity and pressure to push the water through the kind of fiber and membrane. And now Leo's going to be talking about the design.
Sorry? Pictures? Yeah, pictures, please. Okay, so here you can see our pictures. Okay, this picture over here, the third one, is actually upside down. I'm very sorry. It should be turned around. Maybe if you turn your head like this, you'll see it right. Anyways, here you see two channels. Okay, imagine these small particles here are hair. They get stuck on a V-shaped container that you pull out of the machine, or out of this box right here. Right, let's see if I manage to do this. Yes, I do, okay. So, it looks like this. Here, the hair collect. Other bigger particles collect, you know, like makeup, whatever it is. Okay, I'm not gonna put this in, this takes too long. Anyways, here is the Nano Filter we were talking about. Here, only the really, really tiny particles get stuck. We had to do something that was user-friendly, so that nobody wants to like clean up, and it becomes a burden after a certain time if you have to clean up every week, every second week. So we figured we're gonna do 2 filters. This one for the bigger particles, this one for the smaller particles. This one you don't have to really clean up because the system is that this gets finer, so the pores inside here get finer after a certain time. The more particles get stuck on it, the finer the filtration system becomes. And this one, you empty it out every 2 weeks. It's super simple. Just throw it in the garbage and done. So yeah, okay.
All right, I'm going to talk about the science of it real fast. Except instead of talking about silver nitrates and OSM2 nanowires, I'm going to show you this very scientific, very professional claymation video we made, complete with beautiful sound effects by me and my counselor. If it can load.
SNFS, directed by SNFS. A short while later.
Okay. Let's unpack this real fast. So so basically, yeah, basically you have these particles here, these white particles. Those are your silver nanoparticles. The black thing is a nanowire filter, very, very fine. The silver nanoparticles get on the filter, are saturated with nitrates, and basically they stretch out and become part of the filter. In fact, they don't just do that, they make the filter itself finer. So they make the filter better. The silver nanoparticles, then once they've joined with the filter, prevent dangerous particles such as arsenic and lead, which these 2 guys are here, from actually getting in. So we've created a system where the thing we're filtering out actually increases the power and the fineness of the filter. Oh yeah, and I have just a really quick, this is what it looks like. These are what the nanoparticle, or this is what the filter looks like. And just really quick, some discussion. So silver nanoparticles and nanoparticles in general are an area of science that we haven't really looked into, but we know can have very harmful effects. So we created this in a desperate attempt to kind of mitigate these effects before they affect everyone else. Thank you.